Question number 4. Subdivision A. A box contains 50 cuboids. Each cuboid has a mass of 135 grams. The total mass of the cuboids and the box is 7 kg. Calculate the mass of the box. Okay, so we have to give our answers in grams. Fine. So there are 50 cuboids and each cuboid is 135 grams. Now these cuboids are kept inside one box, and that box is what we have to figure out. Mass of the box we have to find out. So they have given cuboids plus box. So what we can do is um, total mass of cuboids. So this can be calculated. So this is nothing but 50 into 135. So on multiplying we get this answer. This is in grams. Then total mass of cuboids plus box is equal to 7 kg. Let me convert this into grams for the convenience. Now if we get the difference of this, 7000 gram is for cuboid plus box and 6750 is only cuboids. So if we subtract that, mass of box will be 7000 minus 6750, which is equal to 250. So 250 grams is the mass of the box alone. Next, subdivision B. A solid cube of side 4 cm is fixed to the base inside an empty cube of side 6 cm. Okay, so I am reading this again. A solid cube of side 4 cm is fixed to the base inside an empty cube of 6 cm. Water is poured into the larger cube until it reaches the top of the smaller cube. Okay, so the diagram might look like this. So let me try to give a rough sketch. So this is a bigger cuboid, the outside one. So this is 6 cm each. And inside that, another cuboid of length, of side length, 4 cm has been kept inside. So this is 4. And then water is filled into this. Water is filled till this small cube's height. Now they are asking to calculate the amount of water poured into the larger cube. So in the larger cube, the water level is only till this whatever I have marked. So this height is 4 centimeter. Right. So volume of water will be equal to that column where the water is there. So that is like a cuboid now. The measurements are 6, 6 and 4. 6, 6 and 4. This minus, there's a cube inside this cube. So there water will not be filled. So that portion we have to eliminate to calculate the amount of water inside. So the cube's measurement is 4. So 4 into 4 into 4. This is 144 minus 64, which gives us 80. 80 centimeter cube. Then Subdivision C. The diagram shows a solid triangular prism of length 20 cm. The cross section is an equilateral triangle with side length 4 cm. The prism is made of wood with a density 0.85. So density is given and this triangle side length is given. So all are 4. That means it is an equilateral triangle. So all the sides are 4 and the length of the prism has been given. So now what are we supposed to calculate? Calculate the mass of the prism. So they have given the formula also. We just don't have to struggle much. So density is equal to, so let me start substituting. Density is 0.85. Mass is what I have to figure out. So let me retain it as such by mass divided by volume. Volume for a prism, for the prism. So volume for a prism is base area into the height. Base is this triangle. The triangle is an equilateral triangle. So I would prefer to go in for this formula, root 3 by 4 a square, which is 4 square into height of the prism is 20 centimeter. Okay, so let's take down all of these. In the denominator, root 3 by 4 into 16 into 20. Now in the next step, let me do the simplification that I can do it here, and 80. So let me retain that mass on one side, push all the numbers on the other side so that we get it something like this. So 0.85 into 80 into root 3. This is nothing but 117.8 centimeter cube. That's the unit. So this is the mass of the prism. Yes. Then let's move on to the next subdivision. There is one more subdivision in question 4. Yeah. Subdivision D. The diagram shows a solid cone with a base radius 10 centimeter and height 24 centimeter. Show that the total surface area of the cone is 1131 centimeter cube, which has been corrected to the nearest centimeter square. Sorry, centimeter square. I read it as centimeter cube. It is centimeter square, and that has been corrected to the nearest centimeter square. There's a hint given in the box. The CSA of a cone with base radius r and slant height L is equal to pi RL. Okay. So TSA of the cone is equal to CSA plus base area. CSA is pi RL and base being a circle, it is pi r square. We can take out the common things. One pi we can pull out, one r can be taken out, and it becomes L plus r. But till now we don't know what is L here. So L is equal to, this is L. The slant height is L. So this portion looks like one right angled triangle. So we make use of this Pythagoras theorem. L is equal to square root of 24 square plus 10 square. which is equal to, um, the final answer is, let me, 676. Square root of 676 is 26. So L is 26. So pi times R is 10 centimeter and 26 plus 10. Pi times 10 into 36. This gives us 1130.9 centimeter square. So this has to be rounded. Once we round it, then we get, so we have proved. So let me write it as hence proved. Mm. So next subdivision. The total surface area of a cone, of the cone, is painted. So they are referring to that same cone which has been mentioned in that subdivision 1. The total surface area of the cone is painted. The cost to paint the cone is $1.71. Okay. And calculate the cost to paint 1 centimeter square of the cone. Give your answer in cents. Right. So this cost is for that entire 1131 centimeter square. So from that we have to take for 1 centimeter square. So cost per centimeter square will be equal to 1.71 divided by 1131 centimeter square. So on dividing this, we get 15.12 in dollars, but we have to give the answer in cents. So divided by 100, so 0.5152 cents. Subdivision B. One tin of paint has enough paint to cover 2.5 meters square. Calculate the number of these cones that can be painted completely using one tin of paint. So one tin can cover 2.5 meters square. One tin can paint 2.5 meters square. That means let me convert this to centimeter square because my TSA is in centimeter square. So meter square, so this is 100 square. The number of cones will be equal to this total of the paint divided by the TSA, which is 1131. This gives us 22 point something, but I have to give it as a whole number. So I tell it as 22 cones.